This section describes the deploy model phase of the ML lifecycle. After you've trained and optimized your model to your desired level of accuracy and precision, you put it into production to make predictions. Standard debugging and logging of the application are part of monitoring the deployed model. You want to capture normal application metrics and track items such as slow queries, high latency, and problem events. However, monitoring the model's output in production is critical to ensure that the model is producing the expected level of accuracy with production data. By monitoring the model, you can also adapt to changes in data patterns that might cause the model to become less accurate over time. From a purely operational perspective, there might not be errors, but that doesn't mean that the model is performing as it needs to. Typically, roles that differ from those who ingested and prepared the data or trained and tuned the model will deploy the model into production. Inference is the process of making predictions on the production data. The code and infrastructure that are related to production are referred to as inference. Notably in production, the model takes in individual samples and provides an output. Compare this to the training environment where the model churns through high volumes of transactions in parallel. As with any application, you want to ensure that it performs as expected in production while managing the cost to operate it. Importantly with ML applications, the choices that you make to train the model differ greatly from those to put it into production. Training jobs batch process hundreds of data samples in parallel, and inference jobs usually process a single input in real time. Therefore, training the model typically requires much higher levels of compute power than the deployed model. Aside from selecting resources to deploy the model, scaling your ML solution means building your environments with infrastructure as code and automating the ML deployment pipeline. You want to be able to respond quickly to changes without a lot of human interventions. This module has looked at each of these steps on its own, and each of them might be performed by different teams who use different resources and infrastructure. But when you need to update the ML solution, you need to reflect updates across all the integrated steps. The 4 different sets of activities that are numbered in this diagram highlight flows that are involved in an update. In this example, if you want to incorporate additional data into your training data set and retune the model, you'd need to initiate the following flows. The data engineer extracts and loads the additional data into the lake. The data scientist brings the new data into the processing phase and then saves any updates to the data and the features. The data scientist then trains and tunes the model by using the updated features and data and saves the updated model version. The ML operations team retrieves the latest model and deploys the latest code to the production environment. Each process relies on different sets of infrastructure that someone is responsible for maintaining, optimizing, and securing access to. This includes the resources that are required to extract and load the data into the lake, the processing environment where the data is prepared for training, the model development environment where the model is trained, and the production environment where the model is deployed. Depending on how your organization assigns these responsibilities, deploying updates to an ML solution can quickly become complex to manage. Automation of these processes not only streamlines updates, but reduces the chance of human error across these integrated activities. DevOps is the combination of cultural engineering practices and patterns and tools that increase an organization's ability to deliver applications and services at high velocity and better quality. Over time, several essential practices have emerged when adopting DevOps. Continuous integration and continuous delivery, or CI/CD, infrastructure as code, and monitoring and logging. Like DevOps, MLOps relies on a collaborative and streamlined approach to the ML development lifecycle. The intersection of people, process, and technology optimizes the activities that are required to develop, build, and operate ML workloads. MLOps focuses on the intersection of data science and data engineering in combination with existing DevOps practices to streamline model delivery across the ML development lifecycle. MLOps requires the integration of software development, operations, data engineering, and data science. The Automating the Pipeline module goes into greater detail about tools and processes to automate data pipelines. Here are a few key points to summarize this section. When the model is deployed into production, the infrastructure typically has different characteristics than the training environment. The code and infrastructure that are related to the production model are referred to as inference. The large number of roles and different environments that are part of the ML lifecycle need an automated deployment strategy. MLOps is a best practice that provides an approach to create a collaborative and streamlined approach to deployments.